Thank you, everybody, for joining today. Really appreciate you taking some time out of your day. We have very large audience today. We have attendees from the US, from EMEA, from APAC. So good morning, good afternoon, good evening, wherever you reside today. So in terms of the agenda today, we are delighted to have some key partners with us as we go through this presentation. We have LSEG, the Data Analytics Group. We also have a key partner, CJC, who is the leading implementation partner in the real-time space. From an agenda perspective, on the Oracle side of things, there's a couple of things that we're going to go through today. The first is why cloud for full-take market data deployments. We've spent a lot of time with customers over the last 12 to 18 months kind of talking about market data on the cloud, but you will notice explicitly here we're talking about full tick market data on the cloud, not a consolidated feed, but the actual full tick. We've kind of talked through what their aspirations are in terms of trying to do that on the cloud, their business drivers, but also their concerns. When people talk about full tick market data on the cloud, that naturally kind of leads to some concerns around network reliability, performance, the cost of actually doing that on the cloud. So we'll kind of talk through some of the drivers and what we're hearing from our customers. The second thing we're going to cover is why Oracle Cloud Infrastructure for full-take market data deployments. Again, we spent time with customers, we spent time with partners, with exchanges, and there's been a lot of kind of objective third-party kind of analysis on what OCI offers, and from both a technology perspective and an economic perspective, and why that's really well suited for full-take market data on the cloud. Now, interestingly, from news this week, if you've seen in the press this week, the announcement that was made on Tuesday regarding the Stargate project, which Oracle was selected to be the AI infrastructure partner, all of that is built on the same infrastructure. So you're going to see the power of what we're doing and the power of what we've built. The last thing we're going to cover from an Oracle perspective is, as we look at both putting full-tick market data on the cloud, what does that mean from an analytics perspective? What opportunities are there once you get that data on the cloud? Obviously, you're going to have two types of subscribers. You could have subscribers on-premise, but you will also have subscribers on the cloud as well. So we're going to go through what our strategy is as it relates to both the streaming side and the analytics side of market data on the cloud. Next, we're going to move on to our key partner, LSEG. They're going to give background on their real-time connector, and they're going to talk about the certification and qualification process on OCI. They're going to share details on their real-time distribution system on-premise and what it looks like when you're migrating to RTC on the cloud. The third thing they're going to cover is the process that they went through from a certification and qualification perspective on OCI. Then we're going to move forward to CJC, who have done extensive testing of the real-time connector on OCI. They're going to talk through their testing approach, give you the full context around that, and also they're going to go through and give you some very detailed testing results from what they've seen on OCI. And lastly, we'll wrap up with a Q&A towards the end. We'll be taking questions in the chat as we go along, so feel free to ask questions, and then we'll address those at the end. Now, before we start, we want to make it a little interactive, so we're just going to bring up a poll question that we'd like people to answer and get some feedback on. Michelle, can you bring up the question? Okay, so as you look forward and as we look at considering full-take market data on the cloud, what are your concerns, right? As you kind of look at that from both a technology and an economic perspective. Is latency and performance your top concern? Are you concerned about the costs, right? Again, we're talking full tick. We're talking about a very large volume of data. There's a lot of costs associated with that. Are you concerned, right, regarding the integration with your existing systems? Obviously, market data is the kind of lifeblood of a lot of institutions. There's a lot of integration points there. What are your concerns there? Is it more in the support side of things? So again, market data being a key mission critical workload, are you concerned around reliability, resiliency, uptime? Or the last comment, or our last option is you have no major concerns, which I guess would be very positive. then you're ready to go to market it on the cloud. So, okay, so we have the questions coming in, lots of great answers coming in. And I think we're just going to wrap up the poll. So, okay. So in terms of the answers we're seeing, latency and performance is the number one concern. Cost is number two. Integration is number four. Support versus system reliability is actually third. And then there is 5% of the audience that has no major concerns, which is very, very, very positive. So thank you for that. So we'll kind of take that into account as we go through our presentations, and I'm just going to share those results. And we will get started. Okay, so moving forward, we're going to move to the oral portion of the presentation. We're going to start off with Moritz Block. Moritz, can you kind of share with us, from the conversations that we've had with customers really over the last year and a half, where it's really intensified around looking at market data on the cloud, what some of the key drivers are for these customers?
Yeah, sure. Thanks, John. So, yeah, I think a key one that we've heard a lot is resiliency. So that one is critical. The ticker plant has to be up, and I think what the cloud provides is resiliency in the sense that there's multiple physical buildings, there's multiple availability domains, fault domains. So there's high availability baked into the cloud, and so customers would like to take advantage of that. And this could look in a couple of different ways. So it could be more of a BCP play where you run that in the cloud, or it could be an active deployment where you have an on-prem ticker plant and a ticker plant in the cloud, and then let your consumers of the data decide where they want to be, or it could even be 100% in the cloud. Tied to that is stability. And that's a key requirement. Obviously, you want just reliable infrastructure that just works. And so customers are looking for that, and the cloud does offer that. A big one is elasticity. So obviously, the markets go up and down, and there's peaks and spikes, and you got to have infrastructure that can handle that. And the cloud provides that elasticity where you can quite easily scale up and add capacity and then scale down again. Another area that is of interest is agility, which is a general benefit of the cloud. A lot of the on-prem installations, there's just not a lot of agility, right? So there's usually big projects that need to be done to do upgrades and things like that. That's all a lot easier in the cloud. So you can pretty quickly, change your infrastructure, update your compute shapes, try new things out, fail fast. That's just a benefit that comes with the cloud. And then I think another really critical one is innovation. And that happens both at the core infrastructure layer, right? So you can take advantage of that as it becomes available. For example, we now have our DPUs enabled on our smart NICs, right? Which greatly increases the packets per second that a smart NIC can handle. So that's something we enable, and you just take advantage of it, right? It now works for you. But the other side of that is innovation, just in general, cloud native services that are available to subscribers of the data, right? Once you have a ticker plant in the cloud, now your subscribers can easily be in the cloud as well and take advantage of things like GPUs and compute grids and other cloud native services that are available. Then I think performance, we'll talk a little bit more about that. Our friends at CJC will cover that one, and they've done some extensive benchmark testing of RTC on OCI. And then lastly, cost. I know it was a concern that was raised, and we hear that a lot from customers where they say, okay, cloud is great, but it's actually more expensive than what we can do on-prem. And I would say that is true. We've seen plenty of cases where that is true with other cloud providers. And so I think that's where we are unique in the sense that our cost model and the way we approach our pricing is different in that we actually compete very well with on-prem. And so we have large customers that picked us that want to go on-prem, but then they looked at our pricing and said, okay, you guys are actually, the total cost of ownership is actually lower. So now that's just a statement, right? Of course, if you have questions, please, if you want to see it for yourself, right, just talk to us and we can show you what that looks like. But yeah, so those are some of the reasons that we see for full tick data in the cloud in general. Yeah.
Great, thanks, Mert. So can you cover the core underpinnings of OCI from both a technology and an economics perspective, and what that means for full tick market data on the cloud?
Yeah, so as a cloud, right, and I'll just state it, we were late, right? So we started late. The other, GCP, Azure, AWS, they were there already. There's some downsides to that, but the upside is the benefit is that we had hindsight, right? So we knew what some of the shortcomings were of the other clouds, and we were able to build a new cloud that did not have these shortcomings. So when you look at market data distribution, obviously what's very important is latency and bandwidth, right? When we build our cloud, we didn't build the cloud for market data, but it turns out to be actually a great fit for market data. But what one of the realizations was with the other clouds was that the network is really the core of the cloud, right? So we put a lot of focus and effort into getting the network right. So what does that look like? It's a non-blocking flat network, right? We don't oversubscribe the network. The bandwidth we advertise is the bandwidth you'll get, right? The network is very flat. So that means minimal number of hops between any 2 points in our cloud data centers, regardless of the service you use, right? So it's a single network. All services leverage that same network. So if you go from, say, your ticker plant and you want to run some workloads on GPUs, right? That is that same low latency, same bandwidth. And so that's a perfect fit for market data. The other thing we focused on was flexible infrastructure. So instead of doing the t-shirt sizes or you having to go through a million different instance types, right? You can just pick your processor, you pick the number of cores you want, you pick the amount of memory, you pick the network bandwidth you want, and that's it, right? And you just provision your infrastructure. So that allows you to really fine tune and right size your infrastructure for your market data workload, right? Which is great, and obviously there's a cost component to that, right? A cost savings component. Same with our block storage. We just have one block storage. We don't have different types. You just specify how many IOPS do you want, how much throughput do you want to support, right? And do you want to auto tune it? Like, do you want to go up and down, or do you want to go up like once a month and then go down again? So that you have that full flexibility. We know that's important to customers, and we put a lot of effort and focus into making that a reality. Now, from a performance perspective, obviously that is critical. And when you step back, what we did, right, and based on the history of our company, we put a lot of effort into the enterprise aspect of the cloud, right? So security, performance, resiliency, those are givens, right? You have to provide that to an enterprise. And so we're so confident with what we build is that we not just have availability SLAs in the cloud, but we also have performance SLAs, right? So if the performance misses the mark, right, there is an SLA for that. And so we do that because we know that is important to our customers. Now, from a pricing perspective, I think that's a key part. In general, our pricing is lower across the board. So when you look at unit cost compared to the other clouds, it is lower. And then there's a lot of things we do not charge for. So usually when we do those bill comparisons, it's very interesting. You get a long list from a competitor, bill of material. We have a very short list because we just don't charge for a lot of things. And so on the network side, specifically as it relates to market data, is that we do not charge data egress fees over dedicated connections. So when you run, say, your ticker plant on OCI and your subscriber is somewhere else, right? It might be on-prem. There's a lot of data that flows from OCI to on-prem. We don't charge data egress fees for that. So this is one of the big, I think this was one of the big blockers to get more cloud adoption in the market data space, because we're talking about such large volumes of data that are flowing through the systems. And so we've addressed that by just not charging for data egress fees, which is great for the market data use case.
Great, thanks, Mert. So let's talk through how we've brought all of this together from both a core technology and an economics perspective, how we've put that picture together to look at both the streaming side and the analytics side of market data, going from left to right.
Yeah. So as we were having more and more discussions with customers, we realized that there is a convergence, right, of the market data distribution and then the market data analytics, right? And so what we've built is an innovative analytics platform that can then take that real-time market data, right? Either process it in real time, process it near real time, or even do more historical types of analysis on that data, right? Have a way to build your models on OCI, run your models on OCI, leverage the latest AI infrastructure to empower these models, and then share data, right? Share data within the firm, share data externally. So that's sort of our view and vision of what this would look like. And as we go from left to right, there's a few things that we've been doing. One is the importance of being close to the exchanges, right? So we have created POPs in different locations that are adjacent to the exchanges. So the latest one we announced was in NY4. So we now have a POP there that connects to our OCI backbone. So from there you go to the cloud region. So what that means for you is, like, if you're in NY4, you can just do a simple cross connect there, right, and get and connect to OCI. We have locations, POPs in Chicago, London, Frankfurt, Singapore, Tokyo. So all the major places is where we have points of presence now, where you can connect into the Oracle Cloud. In some cases, we even have our cloud regions themselves adjacent to the exchanges for very low latency access. And so some of the testing we've done so far shows very good and low latency results, which basically enables moving a bunch of workloads to the cloud, right? There's certain, like, super low latency workloads that are not suitable for that, but the vast majority of what we see is actually suitable to move to the cloud in terms of what the latency looks like.
Yeah, and I think, Moritz, I guess just giving New York as just one example, what you'll typically see from a POP perspective to, let's say, Ashburn, one of our major cloud regions, you're looking about a one-way latency of about 4 to 5 milliseconds, which, again, to Moritz's point, can support a large number of use cases. Also, we've done testing with customers where we've had round trip from the New York metro area to Ashburn, just again as an example, back down to the New York metro area. That was around 7-8 milliseconds. So again, there's a lot of use cases you can support with that type of latency.
Yeah, then so as we talked about, so we do have the right network to move all that data, and then the economics that go with it, which are just as important, right? To do full tick in the cloud. Then from an AI perspective, AI infrastructure perspective, I think this is one where we're just scratching the surface right now, right? So when it comes to the analytics of the market data, we see some AI infrastructure use cases where GPUs are leveraged for acceleration of workloads, which are great use cases, right? So you can reduce like processing time from minutes or even hours to much shorter, which allows you to do more real-time or near real-time analytics on top of the data, right? With much more complex models that are GPU powered. But then there's also the true AI that I think is still fairly rare, right? I know some companies are doing it, but I think there's a lot of opportunity there, and I think this is one area where, as a cloud provider, we're really crushing it, right? From an AI infrastructure perspective. I mean, John mentioned the Stargate initiative that was announced. We pretty much run right now most of the large language models are being trained on OCI, so OpenAI, XAI, Meta. I mean, they all use the Oracle infrastructure, and one of the reasons is the network. So we build actually a very high bandwidth, low latency cluster network where we can build very large GPU clusters, and we're really the only cloud that got that right. And so NVIDIA is actually one of they run all of their internal things on OCI. They did the testing and they said, you guys, your performance is the same as our custom built GPU clusters that we have in our data center. So they picked us for that reason. Now
Great.
another focus is, sorry, go ahead.
Yeah, just keeping track of time.
Yeah, I'm almost done. So one more call out here to we're fully committed to open standards, right? It's sort of baffling to me when I've been in the industry for about 30 years now, and we learned that lesson a long time ago that workload portability, open standards is important, right? And now in the cloud somehow we tend to forget it, right? So there's a lot of proprietary services out there that really lock you into a specific cloud provider. We're not going down that route. We want open standards and we want workload portability. So we're not afraid that you could move your workload away from our cloud. We believe we have a great cloud, and we want that portability because we think it's good for customers. Then lastly, the no egress fees, right? That is over the dedicated connections. That's not just back to on-prem, right? That is also to the other cloud providers. So as a cloud provider, we realize the importance of multi-cloud connectivity, right? And so we have partnerships with Azure, GCP, and AWS. For Azure and GCP, we actually provide a managed interconnect where there's no data egress fees both ways, right? So we made sure that when the data, say you set it up to Azure, we made sure there's no data egress going from Azure to OCI, right? Those are the only places in Azure and GCP where they do not charge for data egress, and so that is available to you. We're working on it with AWS. That they had no appetite at the moment. We think they should do it because it's good for customers. But that's like really a critical piece of this as well, because we realize not all of your subscribers of the ticker plan might be on OCI, right? They could be on different clouds, and so even there the economics work because you do not pay for data egress fees, even to Azure, GCP, and AWS.
Great. Excellent, Moritz. Thank you very much. Okay, so now we're going to move to the LSEG portion. We're delighted to have Jeff Sewell here and also Mahesh as well from the LSEG Data Analytics team. So Jeff, I will hand it over to you.
Thanks, John. And thank you everyone for joining us today. I'm Jeff Sewell. I'm the product manager at LSEG for the Real-Time Connector, or RTC, as what we're hearing about today. And we've qualified the Real-Time Connector at Oracle Cloud Infrastructure, or OCI, to address customer requests to be where they need us to be. Right now, what is the Real-Time Connector? I'm going to make this short and sweet so we can get to the meat of the presentation, but just want to give you a little bit of background. The RTC is a core component of our real-time distribution system, and our on-premise real-time distribution architecture leverages a two-tier server deployment with a multicast backbone. Now, since multicast is not supported in the cloud, our recommended cloud deployment architecture is the two-tier real-time connector, RTC, that leverages a TCP unicast backbone that is supported in the cloud. Right. So it's a highly scalable infrastructure with a top tier caching layer and then a second tier layer that we use for the dissemination or the fan out of the real-time market data. You'll hear more about the benefits of the infrastructure of the capabilities from Mahesh in a moment, right? I want to just give you a little bit of background that takes us back to 2020. And at the time, when our customers asked us to be agnostic, and they asked us to be agnostic because they knew we had built out our real-time optimized infrastructure at another CSP in 2018, and they wanted the flexibility to choose the CSP of their choice and not be locked into the one that we initially chose, right? So that was a nice way of saying just because you chose that CSP doesn't mean we're going to choose that one. So fair point, and that was a reasonable request. And at the time, there were 3 major CSPs. So we qualified the RTC with Category A support at those 3 CSPs by the end of 2021. Again, to address customer requests to be agnostic, all right? Now, why is Category A support important? I'm not going to run through all the details in the product framework support guide, but you should know that Category A is our highest level of support, and the majority of our customers require the highest level of support to move the RTC into a production environment. So I'm happy to say today RTC is now qualified at OCI with Category A support, which is now the 4th CSP to achieve this status, which is why we continue to deliver our customer request to be agnostic and give them choices at the CSPs. And now OCI is another choice for them to consider, all right? The qualification process has been a collaboration effort between LSEG and OCI. We're the subject matter experts on OCI or on RTC, and OCI team are the subject matter experts on the OCI infrastructure. And together, we've optimized the functionality and the scalability of RTC across different OCI shapes. And it's a great learning experience for both teams, for the benefit of our customers, to continue to provide them with choices and to be where they need us to be. As Moritz and John mentioned, the RTC performance evaluation was done separately by CJC, which is a third-party market data technology consultancy firm, and we'll be presenting those results today with the different shapes right after Mahesh finishes. So with that, I'm going to turn this over to Mahesh Bommanaya-Kanahali, who is the development manager for the real-time distribution system, and he'll drill down on RTC cloud architecture, the capabilities, and then run through some of the qualification process for the RTC at OCI. Over to you, Mahesh. Thanks.
Thank you, Jeff. Hello, everyone. So like Jeff mentioned, so we did the RTC qualification, but I'll give a little bit of background about, the typical RTDS deployment on-prem today, and then what is our suggested deployment in the public cloud. One of the other key considerations is we want to make sure all the existing functionality that our customers have come to depend on that has been built up for the last 3 decades continues to function. We continue to evolve with new technologies and with new requirements that comes from the customers. As part of doing this, we realized that we had to scale out, vertically also the RTC component. That's where the extensive multi-threading has happened for us within our product line, and there are various deployment options. And then I will touch upon the qualification details at the end. We work very closely with Moritz to get some technical help as needed, and this has been a great partnership. Yeah. So if you look at a typical on-prem deployment, right? So we have the providers bringing in the data through their feed handlers. It could be LSEG, exchange feed handlers, or consolidated ones, or full tech, conflated, or it could be third-party broker feeds. Customers write their own applications using our open-sourced RTSDK API. So all of those things will enter the RTDS through the advanced distribution hub, where we do the caching and some of the different quality of service like the conflation and the delay. And then it gets distributed out to the consuming applications based on the interest that the applications make to the advanced distribution server, the ADS. So that data flow between the ADH and the ADS is using the multicast backbone. The consuming applications are typically written to the open source RTSDK API with various programming languages, C, C++, C#, .NET, Java, WebSocket, REST. So we support a variety of consumer applications. And then for the purpose of the entitlement and authentication, we use the DAX system that's kind of glued into the ADH and the ADS. So that's the typical flow of the messaging. And it's a highly scalable system, well established. You can do horizontal scaling. You can bring in millions of instruments, and there is a whole bunch of functionality, as our customers know. So when we have to take this into the cloud, what do we do? So in a nutshell, an RTC is basically the top half of the ADH and the bottom half of the ADS. So that is what allows us to preserve the functionality that has been built in for a very long time. So the ADH and the ADS, if you think about it, it's on a multicast backbone. That's the two-tier. Instead, we do 2 tiers of the RTC. The top tier provides the same functionality like the ADH, right? It does the caching. It does different qualities of service, different levels of aggregation or delay or blending of different data types, from various providers. So all those things happen at the caching layer. And at the bottom level, the fan-out layer RTC is where the last mile functionality of the RTDS takes place, right? So that is where we do compression, we do encryption, we do the data conversion. So all these things happen. So it's basically, if you think about it, it's really a mapping of the ADH ADS instead to the 2 tiers of the RTC. Instead of the multicast, now there is a TCP mesh. So that is why it's important for us to make sure that we have guaranteed bandwidth and predictable latency when we do this type of a deployment. So I'm not going to get into all these details. This slide is there mainly to show that when you move into the RTC TCP-based distribution system, the functionality that's been there is continues to work, and we continue to enhance them along with the multicast-based solution. So the various this slide shows that over the last 4 years, all the functionality we have been adding pretty much exists in both TCP-based RTC solution and the multicast-based ADH ADS solution. And about 5 years ago, we had to bridge some of the gaps. So that's the parity that's mentioned there. So all the feature set that the customers have come to know and depend on exists there. So the resiliency model is slightly different. We don't have the full tick-by-tick hot standby. Instead, we have the provider warm standby functionality, but that gives you a greater level of resiliency. You can have multiple standby servers in different regions. So that was not there with the source mirroring or the hot standby functionality. So I talked about the multi-threading we had to do. So, before we went on this journey, all of the data would just flow through a single thread that we call the main thread. So the performance was limited. This was used mainly in small deployments at what we call branch sites, the hub site being the one where the bulk of the data transmission and distribution happened. And then as we started multi-threading this, we added a number of distribution threads or the writer threads. So that's the last mile communication with the client application. There is buffer management, just-in-time conflation, and conversion to, let's say, the WebSocket from our native highly bandwidth efficient RWF data format. And then we support the LZ4 and the zlib compression. And we also support the TLS version 1.2 and now 1.3. And then we added the item threads so that the caching could be offloaded into its own thread, a bank of item threads. That's where we do the caching. that also does the request routing, it does the multiple qualities of service. And then as we wanted to bring in millions of instruments, we knew that if we do just horizontal scaling of the item threads, then it just becomes a connection zoo upstream, right? So, and that also leads to fragmentation of the messages. So that is why we had to add channel threads so that it acts like a funnel. And that way, you know, the message flow is more streamlined. There is better batching of the messages. So this is what has helped us to get equivalent performance, you know, whether it is the two-tier ADH ADS or it is the two-tier RTC. Because of this heavy multi-threading of the RTC, you can deploy it in whatever mode suits your deployment, but performance-wise, we are on par. So for the qualification itself, we work closely with OCI, and we focused on what we consider to be more deployment-centric things. Like we made sure that our qualification, we also did the qualification with the single tier, but we believe most of the customers do the two-tier RTC deployment. And also now there is a lot of interest in containerizing because of the huge compute that is available. So we chose Podman as the container. So we did the qualification with both the VMs and the containers. We did different instance shapes, but you know, for some of the deployments, the optimal one is the 16 OCPU that gives us the guaranteed 16 Gbps bandwidth. And you know, we chose 32 GB because that's usually sufficient. But like Moritz mentioned, you can change the instant shape very easily. So that's one of the benefits. And we have actually now started doing some of the 32 OCPU for some of the larger deployments as part of the qualification. And encryption is very important for various deployments that our customers have. They want to encrypt messages in every segment. So that is why we did the qualification both with and without the encryption. We chose TLS version 1.3 because that's what we support as the most recent version. And the other one is the network load balancer. Yeah, so everybody deploys with the load balancer typically, so it makes it easier. And we started out with the 25 Gbps, and then we extended that to 100 Gbps. Yeah, so that's what we are testing with. And our tests have been with the live data connecting to on-prem, connecting to the real-time optimized feed in the public cloud. And we also ran our tests, you know, with a small number of connections, but also with 100 connections. Yeah, so that's our typical benchmarking test. That is to make sure that we stress the network, we stress the TCP stack, and we stress our application. And also by running tests for a good length of time, we ran it for days. For example, our Podman test has been running now for over 2 weeks. Yeah, so we want to make sure that the long-running connections, that's what the applications do in real life. Yeah, so they stay connected. There are no unknown disconnections. Yeah, so we did that with the Podman, and we did that with the VMs. So that's that has gone well. So that is why, like Jeff mentioned, we are happy to say that, you know, it is qualified in OCI now, and we are releasing RTDS 382 within the next few days. And our documentation that we provide as part of the RTC package as a cloud administration manual that has a chapter on the OCI now. And also we'll be updating our support framework guide to show that the OCI is now qualified and it is providing category A support.
Great. Thank you very much, Mahesh and Jeff. We really appreciate it. I also want to recognize Xiaoming on the LSEG team, who I think at this point may be an OCI subject matter expert. It's very, very impressive what he managed to do on OCI. One quick item here before we move to our partner CJC to talk about the fact that there is the testing here that LSEG have done, both with subscribers on cloud, subscribers on premise. We've also done testing with customers, right? Both, again, subscribers on cloud, subscribers on premise, proving, you know, the robustness of that round trip latency when you do have subscribers on premise. So we've done different variations of this testing in different scenarios. So with that, I'm going to hand it over to Pete Williams from CJC. Again, this team has done tremendous work over the last couple of months on testing this exhaustively. So Pete, I'll hand it over to you.
Thank you, John. Hi, everybody. So yeah, I'm Pete Williams. I'm the CTO at CJC, which essentially means I get responsibility over all the fun stuff. CJC, if you don't know, we're an independent consultancy and managed service provider. We specialize in real-time market data delivery systems and the associated technologies, including cloud. We're 25 years old. We're in London, New York, Hong Kong, Singapore. We're staffed exclusively by market data experts that we've either cherry-picked from the market or we've developed internally for our own training academy. So our role in this testing process was essentially as an independent body that was recognized by both Oracle and LSEG as trusted and respected SMEs. Our independence was crucial for this testing because we are not resellers of OCI, we are not resellers of RTDS. There's no incentive for us. It's purely go out, see what you can find, see what the results are and present them. So our findings are our findings. The brief for us was very simple. LSEG provided aspirational performance levels that they aligned to common use cases across a range of customers. These were from big heavy hitting tier ones right down to sort of small boutique organizations. OCI then offered up 5 sort of standard infrastructure profiles, which we all agreed would be suitable. These range from a micro all the way to an extra large. So the goal was clear: test these use cases against the profiles and see how close to those aspirational performance levels we could get. The aspirational performance levels were specifically set higher than the levels of performance that we see generally to really kind of tax things and test them. So our testing approach has always been to make our testing as close to a real world scenario as possible. So therefore, the data levels, the update rates were all consistent with what we see with production customers. We ensured that the infrastructure that OCI gave us was essentially out of the box and untuned. And the configuration that we applied to RTC was essentially our best practice configuration.
Great, so, thanks, Pete. I think, and to your point, again, on the networking side, I think that's a key point that Pete had raised, where there was no specific tuning or optimization done through the testing. Oracle were not involved in the testing. That was by design. So there's a lot of opportunity here as we look forward in terms of the capabilities of our network, working with teams like CJC and LSEG to kind of push the limits of RTC and its capabilities. Sorry, Pete.
No problem. No, and that's true. And that sort of will dovetail into part of my wrap up. So in summary, with our testing, out of those aspirational performance levels, which you'll be able to see on the upcoming slide, in every single case, we reached the target. So the aspirational levels were reached. And in all but one case, they were exceeded, which we were quite excited about. So you can see here some key takeaways here is the outbound message rates. So 16.2 million messages per second for the extra large. Just to give you an idea, and there's a column there that will show this, that's over 20 gig. So we are talking about some seriously heavy hitting performance. You can see within this slide as well some of the configuration points. So our update size was set to a very consistent real world production type size. We were pretty surprised. We also have an understanding of why we didn't exceed the performance for large. And in future testing, we are 99.9% sure that will also be exceeded. And that goes into the point about the fact that, again, we're talking about completely out of the box OCI. We're talking about a best practice tuned RTC. If kind of let loose on this stuff, we think we can really push this further and beyond. And you'll see there that all of the results here are pretty impressive. And the eagle-eyed of you will be wondering why some of these tests have quite low CPU utilization. That's the overall CPU. Under the covers, main threads would have been maxing out at that point. So if we move on to talk about the latency piece, so again, the key things that we've looked at, latency, throughput, CPU utilization, and network bandwidth utilization, they're really key things here. The latency, once again, really impressive. You can see across, so these two here are two that we wanted to call out, but we're talking really consistent, really low. I mean, the OCI network performed fantastically. It performed in a really consistent and deterministic fashion. And we know that is so important for customers, is to be able to trust the latency you're going to receive. And be able to run your business on a system like this. So there is a very detailed testing document that is going to be available on request. So if people want to kind of deep dive and look at all the graphs, but what we can say really is that real-time connector on OCI has demonstrated outstanding performance. Excellent scalability. And again, I just want to reiterate, this is untuned and unoptimized, and it's still really knocked our socks off. We strongly believe that this is the tip of the iceberg, that there is performance to be mined from this far beyond what we've seen so far. And the performance that we've seen so far is on par, or in some cases better, than some on-prem bare metal deployments. So from our perspective, it was a really enjoyable and eye-opening experience.
Great. Thank you very much, Pete. And I want to thank your team again for extremely exhaustive detailed testing. And one call out before we go to the Q&A, the latency numbers are very interesting. And again, it's great that the CJC team qualified those numbers. What that means is we're talking about latency, obviously within our data center, within and between different compute shapes. What we've seen in real world customer testing is that the latency, if you want to do a round trip from your, let's say, New York metro area to Oracle back, the latency is really only the physical latency, right? You really lose nothing when you go into OCI. Again, that shows how we've built our network. Again, it's a flat, non-blocking network. So you don't have to worry about, okay, what latency am I going to add over and above that physical latency when I go into Oracle? As shown here, it's absolutely minimal. So what you can do is in a different location, either New York, London, Singapore, Tokyo, we look at the physical latency between our local POP and our local in-region data center. That's really the latency you're going to be looking at, which again, looking at more customer testing, when we're talking about latencies, one-way latency, 3, 4, 5 millisecond, or round trip latency, 6, 7, 8 milliseconds, you can support a lot of use cases from a market data perspective with that type of latency. So I think that was one of the key findings, and we were delighted that CJC, again, with his exhaustive testing, kind of confirmed what we were seeing also on customer side and also what LSEG were seeing as well. So again, Pete, Steve and team, tremendous work, and we really appreciate this very objective, detailed testing. So with that, we are going to go to the Q&A.